Hello everyone, welcome back to another video. Today we are going to be solving some really good problems for JEE Advanced from the chapter of quadratic equations. Please don't mind if you hear the voice of like the chirping of birds around, okay? Okay, so let us proceed on to the questions. So here we have our first question. If the equation, here we have our equation alright, has no solution in x and y then, okay fine. If this is no solution in x and y, first of all let us analyze this part. So as we all know, this whole thing, it belongs to minus root 2 to root 2, right? Yes. So this value mustn't belong in this interval, alright? Then only we'll have that part. So there are two cases, either it is like less than minus root 2, alright, or because it is a continuous function, alright, or it is greater than root 2. Okay, so which condition would be satisfied? Look, the coefficient of y square is 1, which is a positive number, which implies it is an upward opening parabola, alright. So it cannot be like less than minus root 2, that type. Okay, so this thing is rejected, alright. This thing is rejected, okay, because it cannot be always negative. At extending infinity, you can see it will tend to infinity itself. So you cannot say that it is always negative. If it is less than minus root 2, it has to be always negative, right? So you cannot say that. So this case may be possible, alright. So when is this case possible? When the minimum value of the quadratic is greater than root 2, then only it is possible, right? Where does the minimum value of the quadratic occur? I can also say that the minimum value of quadratic is minus d by 4a, but here this is more convenient, that is substitute minus b by x is equal to minus b by 2a, and from there I manipulate. Okay, so let us substitute. So the minimum value occurs at y is equal to half, right? So 1 by 4 minus 1 by 2 would be minus 1 by 4 plus a. Here I am doing the manipulations already. Plus a is greater than root 2. So simply a is greater than root 2 plus 1 by 4. Okay, so this is our answer. Which option does it match with? D option, right? So this is our answer. Let us proceed on to the next question. So this question is based on the same concept, so I will give it to you as homework, alright. Please comment down the answer in the comment section. Let us move on to the next problem also. Please take a look at this problem. It is more like based on calculation itself. So yeah, let me give you the idea. So we have been given a quadratic equation and p is the root of this equation, so we need to find the value of this expression over here, which is given. Okay, so since we have a quadratic equation, let us try to reduce everything we have here in terms of quadratic itself, so that like we can proceed properly. So first of all, in the numerator, let us use the a cube plus b cube formula for our convenience. Okay, from here I am starting. Okay, so it would be a plus b a square p plus 1 p square minus p plus 1, right? Yes. So here we know the value of p square minus p, right? Like we have been given the quadratic equation, let us substitute p over there so that it is convenient for you to see. Okay, so p square minus p is over here, p square minus p is over here. I can substitute easily. Okay, we'll do that in the next step to avoid any sort of confusion. Here we take out p square common. Okay, so we'll be left with p cube minus p square minus p plus 1, alright. Okay, so this thing is equal to p plus 1 times, look, p square minus p is equal to 3, right? So this whole thing, this whole bracket would be, let me point out, this whole bracket would become 4 because we know the value of p square minus p. Okay, fine. Whole divided by p square, we may substitute p square as p plus 3, but why do that now? We don't know what will happen in the future of the question, so let us keep it in. Okay, the second thing which I can think of is, here in the numerator I have p plus 1, I want to cancel p plus 1. Let us check if p is equal to minus 1 is the root of this equation. And you will see that p is equal to minus 1 satisfies this equation. So let us factorize over here itself. You know that the general method of solving cubic is hit and trial only, right? So here we'll get p square, p cube plus p square, we need minus p square, so minus 2p. Now we have minus 2p, we need minus p, so plus 1. I can like factorize orally like this by looking at the coefficients in the original expression and over here. If you don't know how to do that, you can prefer long division or whatever you want. Okay, fine. So this will become 4p plus 1 by Okay, p plus 1 gets cancelled out, right? P plus 1 gets cancelled out, right? So p plus 1 gets cancelled out. We'll be left with 4 by p square times p minus 1 whole square, right? So let us now convert to linear into linear. Then only we'll get another quadratic expression, right? So I'm substituting p square as from this expression. From this expression over here, I am substituting p square as p plus 3, and here also I'm substituting p square as p plus 3. Okay, so we'll be having p plus 3 times, this would be 4 minus p. Okay, so what will be left with is 4 by let us write the coefficient of p first. It will be p plus 12 minus p square. So minus of, let us write p square as p plus 3 itself. So we'll be having the answer as 4 by 9. That's it. We have our answer, it is B. So let us proceed on to the next question. So here we have an easy question. Let us read and do it quickly, because yeah, it is easy, alright. So we have been given that a square plus b square plus c square is greater than 0. So this implies that any one of ABC is non-zero, okay. And we have our quadratic equation. We need to comment on the nature of its roots. So let us find the discriminant and comment on the nature of its roots. So discriminant is equal to b square minus 4ac, right? So a plus b plus c whole square. So listen over here, the notations I'm using. I'll be using summation a square for a square plus b square plus c square, and summation ab for ab plus bc plus c, alright. So please know the notations which I will be using, okay. So b square would be like this term ka square would be summation of a square plus 2 times summation of ab, alright. Okay, fine. And minus of 4 summation a square minus 4ac wala thing. Okay, fine. So my discriminant would be 2 summation ab minus 3 summation a square. Okay, fine. So now I need an inequality for the discriminant, because I need to tell whether it is positive or negative or 0, alright. So these 3 cases I need to comment on whether what sign it will take, okay. So what I'm going to do is, look carefully, you would be knowing this inequality, right? A square plus b square plus c square minus ab minus bc minus ca, this is greater than equal to 0. Why? Because this converts to half times a minus b whole square plus b minus c whole square plus c minus a whole square, right? So I can say that it is greater than equal to 0. You would have read this like in the beginning of 11th itself. If not, learn it now. Learn this inequality now, and that it converts to this, okay. So let me delete this part now, so that we can have space to write the answer. Okay, fine. So what I can say is that my summation AB is less than, like from that inequality, my summation AB is less than equal to summation A square. So this whole thing is less than or equal to minus summation A square. Now we know that this whole thing is positive. We have been given that summation A square plus B square plus C square is positive, alright. So this whole thing would be negative, of course. So our discriminant is negative, hence we'll be having imaginary roots. That's it. Where is the option? No real roots. Exactly. Okay, let us proceed on to the next question. This question was quite easy, and if you didn't know the concept, learn it now. Okay, so what we have been given is that P, Q1, Q2 are 3 real numbers, and a relation is given between P, Q1, Q2. Okay, P, Q1 and Q2. And we have been given like 2 quadratic equations. So since we have to comment on the nature of roots, we'll be calculating the discriminant for each one. Okay, first of all, let us write the condition over here that P is equal to 1 plus Q1 plus Q2. Okay, fine. So for E1, let me write the discriminant as D1, which would be 1 minus 4Q1. Okay, let me write the discriminant for E2 as D2, which would be equal to 1 P square minus 4Q2. Alright. So what I'm thinking of doing is adding these two or multiplying these two. But adding these two seems more convenient, right? Because I have a relation with like linear equation, right? I have a linear relation between P, Q1, Q2. So adding or subtracting would make more sense. Why am I adding? Because when I add, I can see that like q1 and q2 will be having the same sign, right? So I can get q1 plus q2 term over there. That is why I am adding. Okay, so d1 plus d2 would be p square plus 1 minus 4 times q1 plus q2. Let me replace q1 plus q2 with p minus 1. Okay, so this will become p square minus 4p plus 5. All right. So as you can see, the discriminant of this thing, this whole expression would be 16 minus 20, which is minus 4, which is negative. Okay, which implies that this whole thing will be positive. This whole thing will be always positive. Okay, since this thing would be always positive, my discriminant is the sum of discriminant d1 plus d2 is always positive. Okay, so consider this case that even if one is negative, the other has to be positive in order to yield a positive result, right? So at least one of the equation needs to be having a positive discriminant. Okay, so at least one of the equation has distinct real roots. Okay, so option B is correct. This was kind of an easy question, but yeah, you needed this to know this manipulation that you need to add there to the discriminants. Let us move on to the next question. So here we have our next problem, and we have been given a quadratic equation, and the solution set for this inequality would be this quadratic inequality. Notice the word quadratic here. This implies that a cannot be 0. Okay, so we have been given that the roots of this quadratic inequality, the solution set of this quadratic inequality is 2 to 3. Okay, so we need to find the solution set of this quadratic inequality. So first of all, notice over here that we have been given that this quadratic equation is positive only in a certain interval, in a finite interval. Okay, so from here we can infer that it is a downward opening parabola, because in an upward opening parabola we would be having, if 2 and 3 are roots, then you would be having this interval in which it is positive, this interval in which it is positive. All right, so that won't be true over here. We have a finite interval over here. Okay, we do not have an infinite interval. So what we can say is that it is a downward opening parabola. Okay, so first thing, this is clear, get it cleared up. Now the second observation is that, can you see that if this equation has alpha and beta as its roots, then this equation will have 1 by alpha and 1 by beta as its roots. Can you see that? So this equation can be written as, since the interval is given, this equation can be written as ax minus 2 x minus 3, right, greater than 0. Since a is negative, I divide by a both sides and the sign changes. Let me write it a bit more neatly. Okay, so we'll be having ax minus 2 times x minus 3 positive, and if we divide by a both sides, the sign will change. Okay, because a is a negative quantity. Okay, so now here also we'll take c out. We know that the roots here are 1 by 2 and 1 by 3. Okay, we know that the roots here are 1 by 2 and 1 by 3. So what we can say is c times x by, we can write this expression as c times x minus half x minus 1 by 3 is negative. So how do we comment on the sign of c now? Look over here, that it is really easy. You'll come to know this is a downward opening parabola, right? On the original one. So you can see that f0, what is f0 over here? F0 is c only, right? So here you can see that c is negative. Okay, so from here itself you can tell the sign of c. So from here what I can tell is, that I'll be dividing c both sides, so the sign will reverse. Okay, so this thing is greater than 0, and my solution set would be x belongs minus infinity to 1 by 3 union 1 by 2 to infinity. Okay, so it is done, and we'll be having C as a correct option. So here we have our next question. I thought I would make you revise a dual concept problem also. Well, it is an easy question. I added this to increase your confidence after so many questions. Okay, so fine, let us do this question. So let us bring all the terms with quadratic this side and let us analyze. Okay, so I brought it over here mentally, and now let us analyze. So this thing you can clearly see, you will intuitively see that this can be written as x times x plus 2, right? Okay, let me use a permanent color. So this can be, I'll use white, no, not white, because this thing is white, right? So I can write this thing as, this bracket as 1 by x, x plus 2, right? Similarly, notice that since you factorize this one, you'll get the idea, let me factorize them all, okay? So this thing can be written as 1 by x plus 2 times x plus 4. Similarly, this thing can be written as 1 by x plus 4 times x plus 6. This thing similarly can be written as 1 by x plus 6 times x plus 8. Do you notice a pattern? The difference between these two is 2, the difference between these two is 2, the difference between these two is 2, and the difference between these two is 2. So now I'm getting thought of telescopic series. So let me multiply and divide by 2 this expression. Let me bring it over here and now multiply divide by 2. Okay. So I divided by 2, the multiplication goes in the numerator, and the numerator over here can be written as x plus 2 minus x. Here it can be written as x plus 4 minus x plus 2. Here it can be written as x plus 6 minus x plus 4. Here it can be written as x plus 8 minus x plus 6. So what you will be left with is 1 by x minus 1 by x plus 2 plus, let me make a separate bracket, plus 1 by x plus 4 minus 1 by x plus 6 plus 1, no, here it will be 1 plus 1 by x plus 2 minus 1 by x plus 4, okay, plus 1 by x plus 4 minus 1 by x plus 6, okay, plus 1 by x plus 6 minus 1 by x plus 8. Don't you get the feel of telescopic series? These two cancel out, these two cancel out, these two cancel out. Now ultimately you will be left with 1 by 2, 1 by x minus 1 by x plus 8. Let me do the calculation mentally. So it will be 8 by x times x plus 8, okay. And what is this thing equal to? This thing is equal to 1 by 5, all right, and we need to find like the product of values of x satisfying the equation. So this is equal to 1 by 5, right? Okay, fine. So this reduces to this, okay. So 20 is equal to, I'm cross multiplying, it is equal to x square plus 8x. So finally I'll be having x square plus 8x minus 20 is equal to 0. I need to find the product of roots, right? Product of roots is minus 20, that's it. Answer would be D. So here we have our next question. First of all, let us read the question and then proceed on to the approach, okay. So I'm having something like, I'm having an equation over here and I need to find the difference between its maximum root and minimum root. So you'd be knowing that of course I need to find the roots for this, right? So I'll be telling you two approaches. The first one is for like both students of class 11th and class 12th. And the second one is more like it is for class 12th itself because I'll be using a lot of calculus in that. Okay, but the second approach is a must watch for 12th standard students because you will get your concepts cleared in that. Okay, fine. So let us proceed. So here I have an expression. So clearly I cannot just open the bracket because it will be too lengthy of a calculation. So what I'm going to do is for like a symmetrical calculation, first of all I'm going to find the average of these two, arithmetic mean of these two, which will be x square minus 6. And now what I'm going to do is substitute x square minus 6 as t in order to obtain linear expression, because linear expression in the brackets, because like linear expression helps a lot in the calculations. So as you probably guessed, the calculation will be easier this way because we'll be having somewhat symmetrical equations, symmetrical expressions. And from here, can I leave the calculation to you in order to find the value of t and subsequently the value of x itself? Okay. Can I leave this calculation to you? So 11th standard students, please tell me the answer to this question in the comment section without seeing the answer that I reduce in like the second solution. And for the 12th standard buddies, let us move on to the second approach, which will be really beneficial for your concepts. Okay. So here I have this expression as x square minus 5 power 4 plus x square minus 7 power 4 is equal to 16. So what I thought was look, there is everything in terms of power 4, so why I not write 16 as 2 power 4? Okay, so now you would be knowing this, that if I do a power 4 minus b power 4, I'll get something like a square plus b square times a plus b, a minus b, right? You'd be knowing this. This is pretty obvious. Okay, so I'm going to use this itself. So what I thought was, let us move like this 2 power 4 this side, but then I had a problem. Will I club it with this term or will I club it with this term? So I was like, let us make cases and club it separately. So first cases, I'm clubbing it with x square minus 5 power 4. So this bracket represents a square plus b square. I'm not going to calculate it because it is not going to be of any use. So here I'll be having a plus b, a minus b, right? I did the question. That is why I can say that this term in both the cases is not of any help. So I'm going to represent using this sort of bracket. So what we'll be having here is a plus b, a minus b, right? So it'll be x square minus 3 times x square minus 7 plus x square minus 7 power 4 is equal to 0. So from here I can take x square minus 7 common and I get something like x is equal to plus minus root 7. Okay. Now let us move on to the second approach. Not the second approach, the second case. Okay. So in the second case, I club it with x square minus 7 power 4. So similar calculations. I think you can deduce what I am writing over here, because I already told you the concept now, alright. Just the calculation part left. Plus x square minus 5 power 4 is equal to 0. So from here we get x is equal to plus minus root 5. Okay. This thing. So now I have gotten 2 roots. Now I don't know, like 4 roots, not 2 roots. And now that I've gotten 4 roots, I now think that this is an 8-degree equation. And the maximum roots it can have is 8, but I only found 4. I had a suspicion that since this approach clicked to me, maybe there are only 4 roots in the equation, but I was not sure about that. So what I did was, I tried the graph. I was like, if this doesn't work, no problem. I'll move on to the second approach, but let us try this. This is a non-intuitive approach, alright. So it is not advisable to use these kinds of approaches in exam, but yeah, for practice and for improving conceptual understanding, we can do this, right? Okay, so let us proceed now. Too much of chit chat. Done. Okay, so now I was like, in order to comment on the roots, since I'm not going by the pure calculation method, let me go by graph. Okay. So in order to draw a graph, what you need to do is, first of all, you need to calculate the derivative, right? So in the derivative, what you get is something like this. You get the derivative of the equation as this. Okay. So from here you get that x is equal to 0 and plus minus root 6. Okay. You can do the solving part yourself. I am here to tell you the concept here. Okay. So what happens, let me draw a bit neater graph. So what happens is, let me show you. We are going to draw the graph, right? Okay. So for x tending minus infinity and plus infinity, you can tell that the function tends infinity. Okay. So the function would be something like this. Now let us comment on what happens at x is equal to minus root 6 and x is equal to plus root 6. Okay. And what happens at x is equal to 0. So you may notice that, let me write the function over here. X square minus 7 power 4 plus x square minus 5 power 4 is equal to 16, right? So you may notice that this is an even function. This whole thing is an even function, right? So what we get this side is what we get this side. So this x is equal, and at x is equal to 0, the value will obviously be positive, because 7 power 4 plus 5 power 4 minus 2 power 4. Obviously it is positive, right? Anyone can tell. So it will be something like this at x is equal to 0. Okay. Now let us comment on what happens at x is equal to minus root 6 and plus root 6. Okay. So let me get the graph over here and then we'll comment on what happens at these two values. So since that it is an even function, what happens at x is equal to minus root 6 will happen at x is equal to plus root 6, right? So let me tell you something. If this thing happens, let me draw it a bit neater. If this thing happens, like if the graph doesn't touch over here, if the graph doesn't touch anywhere, like doesn't touch or intersect anywhere, we'll know that we'll only be having 0 roots. But I already found 4 roots, right? So in order to have, and those 4 also distinct, so in order to have 4 distinct roots, this thing has to intersect the graph, and this thing also has to intersect the graph since the function is even. Okay, so what I can tell is, yes, my assumption was correct. There are only 4 roots. There are only 4 roots, okay, which are plus minus root 5 and plus minus root 7. So what is the difference between the largest and the smallest root? It is it is 2 root 7, right? Root 7 minus of minus root 7 is 2 root 7. So this is our thing. This is our answer. So you can see that this is equal to 2 root 7 and this will be the correct answer. It was like the second approach was not a really intuitive approach, but a really good approach for conceptual understanding. So I would advise you to use this approach again for practice purposes, okay? And maybe someday it may be of some help in some question, okay? The same sort of thinking may be of any help in some sort of question, okay? So that is why I advise you to practice the second approach also, and that too thoroughly, okay? Thank you for watching this video. I'll see you in the next one.